I've just took a lovely 3D scan and now I want to measure it. So let's find out how. Welcome to Making for Motorsport, where we make more, spend less and go faster. So on the last video I did a comparison of 4 very popular consumer grade 3D scanners, and as part of that comparison I scanned this, a 123 block, and then I measured it and used those measurements to compare between the scanners. And I also said this. So I'm going to bypass that step and put this measurement process with GOM Inspect and also another slightly less accurate one with MeshMixer on the Patreon page, but I've decided to put it on the main channel anyway. So that's what we're going to do. So we're going to look through the variety of different ways, the good ways, the bad ways, that you can measure a part like this or inspect part sizes from a 3D scan. So let's get into it. So the first thing to do if you want to follow this along is to go to the website, link in the description, and go to 3D scanner reviews and comparisons and click here where you can download the files. So I will be using the 123 block files and I'll be using the lizard one. I've already downloaded it and you can see it here. Look at that. Lovely. And that download is free for everyone, so you can have a go at it yourself. So before we get back into it, let's just remind ourselves what the 123 block is. It is 3 inches by 2 inches by 1 inch, and that is the size of it. And this is a fairly cheap one, but they're used to make sure you can set things up off a machine bed. So if you're machining something on a mill, for example, you can set it up and you can be pretty sure that you put one of these down, anything you put on top of this is going to have exactly the same flat, planar surface as the top of the machine. Now, totally upfront, what we're getting into here is kind of tickling at the edges of GD&T, so that's geometric dimensioning and tolerancing, which is a massive subject. People spend their whole lives working in this field. There are whole qualifications and just huge amounts of knowledge to really be able to just characterize what that is. What we're going to do is skirt the edges of the knowledge and just try and work out what's the most practical way that a backyard mechanic such as you or I could measure something as accurately as possible using a 3D scanner. So we're going to start off in MeshMixer. And MeshMixer is a really, really powerful program. It is an old one. It's been around for a while, from Autodesk, no longer supported or developed, but it's got some really great tools. So let's jump into it. So the measurement tools you'll see are under the Analysis tab. And there's lots of different ways you can do it. You can go to Units and Dimensions, and you can literally just drag apart from there to there and you've got a measurement, but that's not particularly easy to do. It's all right if you're in one view, so you can, we'll zoom all the way in there to there, at which point we've got a number 24.88, but it's not precise, is it? And most CAD programs will do this. You can do this in Fusion as well, but it's not quite the scientific answer that we're looking for. So let's go to the Measure tab. So this gives us a few other tools. So we've got different types of measurements. So we can measure between objects with a single click, and the software does stuff for us. So let's start off with this one. So this looks very much like I pick that part and it measures through the part internally to the other side. So that could work for us. Then actually that looks pretty good. So that red line goes from that side there to that side, and as you can see it's going through kind of pretty much square, because this is highlighted. It's going through normal to the surface. That means wherever I clicked there, it's going at 90 degrees. So if I click on this surface, it goes 90 degrees to that surface, or that particular individual facet, that little small face that these STLs are made up of, it's going through. So you can see that's also pretty good. Is it straight? Is it absolutely perfectly perpendicular to this face? No, it's not quite normal. But it's getting us about there. So you can see here we've got 3 numbers on the side. So generally this is the nominal, this is the maximum, this is the minimum, and that's to do with whether you move your mouse and other measurements. But for now we can just look at the middle one, and the help file on MeshMixer is actually really useful. So you know that most of the answers are in there. You can click on here and we can click on every bit of this, and you can see that actually as we click through, that number's changing. Yeah, okay, not a lot, but it's changing significantly enough. It's changing by maybe 0.1 of a mil. So considering that we want to get the most accurate answer possible, it's not great. That's one way of doing it, and that's quite flexible, but it's not got the science to it, the science that we want. There's to have some real confidence in the answers. But MeshMixer, great tool. Download it, use it, learn it. If you're playing around with 3D scans, it is fantastic. And also, you can open some really, really big scans, some like 1 gigabyte STLs. It takes a while to open, but once you're there, you can fly around them in a way that very few other 3D programs can handle. So let's look at another way. So the next software we're going to use is Fusion360, because quite honestly it's the one I've got, but you'll be able to do this in pretty much any of the CAD software. Other packages might have more advanced tools. I don't know, you have to go and look for those yourself, but this is what I have. So what we can do is insert the mesh. Now I could spend a long time orientating this to the global coordinate system, but I've got other videos on that. You can go and have a look. If you are interested in that, drop something in the message. In fact, if you're interested in anything else, please drop something in the messages, in the comments, and I'll look at doing a video on it, or I'll potentially just do a short on it to kind of show you guys how it's done. Anyway, so let's just do some measurements. So it's actually dead simple. We can just go to inspect, measure, and we can pick up a point on there, position X1, and we can pick up a point as close as we can do opposite on the other face, and there you have it. So we can do that, and there we go, 75.653. There you go. Lovely. But we've still got the same problems we have with MeshMixer, in that, is that perfectly flat? No, not really. Am I going, you can see all the different facets there. If I pick a different facet there, I mean, it's not perfectly flat in that direction. It's all just a little bit messy. So one of the things we can do is use some of the reverse engineering tools that are in Fusion360. So first task is do not capture design history, and then we can construct a plane through 3 points across the top here and see if that generally looks right. It doesn't look too far off, no. And then we can construct an offset plane from this down through there. So that's going pretty much through the middle of the part, so I'm happy with that. And then I can create a mesh section sketch. So I can select the body, and then I can select that plane. So if I turn off the body and turn off this other plane, that gives us this sketch. So if I right click here and I click, if I go to the sketches, sorry, then I right click, edit sketch. So I can go to fit curves to mesh section, and I can actually just do a line, and I can try and pick up this line. Okay, and then I can do exactly the same thing again and do at this end. But you can see how much that line varies, and that's just the noise in the mesh, noise in the scan, and you're never going to get away from that unless you're going for a really, really high-end scanner. And even then, there's still going to be variation. It's just going to be smaller. So now I've got 2 lines that actually I can go in here and I can pick them up, and I can say, okay, they're 1/2 degree apart. and they are 75.53. So they are half a degree out of parallelism, and they are 75.53 millimeters apart. Okay, we've got a bit more information there, but that's a very long-winded way of doing it. Is there a better way? Well, in the video, I used GOM Inspect, which is full-on geometric dimensioning and tolerancing software. So let's have a look at that. So GOM Inspect is easy to download, but you have to know where to look. So we start off with Google, not too tricky so far, which takes us to the GOM Inspect page. Now, GOM Inspect is part of the Zeiss group, which are, high precision optics, and they do some pretty fancy stuff. So the fact that we can use this software, even in a cut down form, is pretty bloody brilliant. Anyway, so to download, you go to the products, the GOM Inspect Pro, and you can see the kind of stuff this software can do. It does reports, it does all manner of fancy stuff, but at the bottom of the page you see this, and we need the GOM viewer. So go to download that, and we only need the top file. So click there. It's a 1.7 gig download. It might take a while. Go get it, beer boys. You've earned it. Now you install it in much the same way as every other Windows program in existence. So just click on the license agreement and sign your life away. Now this is the landing page. So you click GOM Inspect and it'll open this page. And if you click that new project, it wants you to register, and you do have to register. But once you've done that, you can open a new project and you're in. So let's make a start. Let's import that same part. So we go in, import file, and we'll go find it. 123 lizard. There's a new part, default millimeters, and there we have it. So what we're going to do first is we're going to do an alignment, because this is essential. So we're going to do a 1, 2, 3 alignment. So we can come up here and we can pick the alignments. And there's lots of different options. 1, 2, 3. We're going to do Z, Z, Y, Y, X. No, we're going to do X, X, Y, Y, Z. So 3 points. So control 1, 2, 3. So those 3 points will define a plane that will sit perpendicular to the x-axis. That and that, those 2 points will then define a plane for the y-axis to sit on that will be 90 degrees to the x plane, x-axis, sorry, and then the final point we'll measure will be there, and the z, that will give us the direction. Now you can see here we're already aligned to the global coordinate system. Now I can, at the moment Z's pointing down, which I don't want, I want Z to point up. So if I click line positive, unclick that, it changes it round. And there you have it. We are now, so I can click and use these tools, and I can use the global coordinate system to navigate. And if I wanted to, I could now just export that as an STL and it would be aligned to my global coordinate system, which is really quick and easy once you've got all the software installed. So it's worth having just for that. So we've got this aligned, and out of all of the techniques we've done so far, the biggest issue has been that depending on where I pick on that surface, I'm going to get different answers, because that surface is not a true plane. It is not anywhere near approaching a true plane. It has got lots of little triangles. It is lumpy. It is bumpy. I mean, look at that there. So you can see that is not a particularly great surface to measure from. And all scanners will do that. It's not just the lizard, all scanners will. So what do we need to do first? And what this software really lets you do is it lets you use statistics to define a true plane on that surface. So let's do that first. So we're going to go to the construct section and we're going to go to plane, and we can use fitting plane. And then we come over to here, and you can see software tells you what to do. You put control and then left mouse button to base it on that surface. And straight away you can see we've got some information. What's the software doing? Well, I selected one point on that surface and it is now selecting all the points that are close enough to it and are within 3 sigma. So what's sigma? Sigma is a standard deviation. Again, we're not going to get into the huge amounts of stats here because this video will go on, but just trust me, it's selecting all of the relevant points that are close enough to the point that I selected and going, right, I'm going to look at all of these points and take these into account when I try to work out where the plane is on that surface. You can see the points that it's selecting, green are, I think, below it, and sorry, red are below it or in, and green are the other side. So you can see how they fall either side of the plane. And because we've got Gaussian best fit, which is again statistics, but that's essentially using the normal curve and trying to not put it directly in the middle like an arithmetic mean, but it's trying to have as many points broadly on one side as the other and have an even spread between the two. So if there's any geeks or any hardcore stats fans out there, yes, I know it's not quite this simple, but the whole purpose of this video is to bring some really powerful tools to you guys. So if I was just to weigh you down with all the stats behind this, number one, I'd never get this video made because I have to remind myself of what they all are, and second, you'd never watch it. So let's just get stuck in. So we now have there, we've got 5,761 points selected, and the max deviation is saying that out of all of those points, they are less than 0.5 millimeter apart from each other. Sigma tells you what the standard deviation is between them, again, stats, and the residual tells you the error that they can't allow for. The statistics don't quite mop up. So the lower that number is, the better, and it's a pretty low number. So there you go. So what we can do then is click create. And there you have it. We now have a plane. And that plane, we turn off the mesh, is a perfect plane. In the software, that is a perfectly flat surface. Excellent. It's the first one we've had all video. So we've put the mesh back on, and we're going to do that a few more times. So now we've got our 1, 2, 3 block defined by planes. Wonderful. So now we've got a surface that has no lumps and bumps. So we can actually now do some proper measurement on it. So what I'm going to do now is measure between them. So I can actually go in here, and now I've got these surfaces, I can properly go in and inspect. So I can inspect flatness, obviously is of no real use here, but I can measure perpendicularity, I can measure parallelism. So if I want to now, I can go to town on this and really inspect it and really understand it. But if I just want to do a simple dimension, then I can go back to here and I can go construct 2-point distance. And I can basically go and click 0.1, and then I can go and pick 0.2. Shift and control, just as the instructions say, 0.2. You can see that that arrow is not straight in virtually any direction. But that's okay, because we can go here and I can edit that point. But I don't want to edit both points, I only want to edit one. So what I'm going to do is I'm going to make that, because I'm measuring in X, I want the Y value and the Z value to be identical. So I can go here and I can change this one to match this number here, 4405, and I can change minus 14 to go to minus 11.753. And there you go. Now you can see So that point, move that out of the way, is completely straight. So that line now is completely in line with our global coordinate system. If I reopen that dimension, edit creation parameters, I can see it is 25.781, which is 0.3 larger than what it should be. So it should be 25.4. That's 0.381 larger. So shade over 1/3 of a millimeter. So let's just do that again. So we can go to distance, 2-point distance, and we can select 1 point there and then the other point there, and it doesn't really matter where we're doing it because we're going to go in and we're going to change it just like we did before. Now this time we want the distance to be in the Y axis, so we're going to change X and Z to be the same. So 16.677 and minus 10.842. And 75.6. Now, the problem is these faces aren't parallel. So if we measure somewhere else, they will be slightly different, but that's all part of understanding how the scanner sees this. So there is lots and lots of really, really good tools in this software. And I don't know how to use the vast majority of them, but you guys out there can now download this software, get stuck in, and yeah, really start using it. I'm going to leave the video there because quite honestly, a massive piece of software like GOM Inspect, you could go on for ages, but there's enough tips and tricks in there across various pieces of software to get you guys started. If you want to see something different or something specific, then please put that in the comments. And you're still watching this now, so well done. Give yourself a pat on the back and give me a thumbs up. I think everyone deserves it. And if you like this type of content, then please hit subscribe and the bell so you don't miss anything in the future. It really does help the channel. If you want to support the channel more directly, then please consider joining the Patreon and these wonderful human beings here. Alternatively, check out the shop on the website and you can have one of these fine t-shirts with Making for Motorsports across your moobs. You may have pecs, in which case, well done, the t-shirt will look even better. So on that note, I'm going to say thank you very much for watching. Stay safe, stay hydrated. What a lovely, lovely website. Isn't it fantastic? Oh,